Again, carrying on having a look at different representations of data, we have here proportional pie charts. Now in A-level statistics now you will no longer have to draw proportional pie charts. I am just going to start the video off though by explaining how that would happen. So in AS statistics you do not need to be able to draw the proportional pie charts. However, you do need to be able to interpret them. The area of each pie chart is proportional to the data that the pie chart represents. So if we did have two sets of data, let's say that one of them had 240 pieces of data and another one had 360 pieces of data. Now I've chosen these numbers because they're quite easy to work with. You could even say, let's make it a bit simpler so that people don't get confused. Let's say 24 and 36. So 24 pieces of data and 36 pieces of data. Now, if I wanted the area of my smaller pie chart to, let's say, be 20 centimetres squared, bearing in mind that the formula for the area of a circle is pi r squared, that means that my pi r squared is going to equal 20 centimetres squared. And I can rearrange this to find out the value of r by dividing by pi and then square rooting my answer. That tells me what the radius of the circle is, and then if I needed to draw it, it's much simpler to do so. However, for my second pie chart, because the first pie chart had 24 pieces of data and the second pie chart has 36 pieces of data, if I did 36, if I go into my normal calculator mode, 36 divided by 24, I get 1.5. That tells me that the area for this second pie chart should be 1.5 times the size of the first pie chart. This area of the first pie chart was 20. 1.5 times 20 gives me an area for the second pie chart of 30 centimetres squared. And again, that's using pi r squared equals 30, dividing through by the pi, and then square rooting our answer. And then we can draw our pie chart. As I said before though, you don't need to be able to draw them, but as a bit of an extra understanding of how this works, that's how we would do it. So here we have an example. We have an advertising campaign to promote electric showers. Consists of a mail shot which includes a prepaid postcard requesting further details. Prospective customers who return the postcard are then contacted by one of 5 staff. So we've got Gideon, Magnus, Gemma, Pandora and Mervet. The pie charts below represent the number of potential customers contacted and the number of sales completed during a 1-month period. So you can see here that this is the number of people contacted and this is the number of sales made. This is in line with what we would think would happen, that they would contact everybody who returned the postcard, but not all of those people would then go on to make a sale or buy a product. So that's why the sales pie chart is much smaller than the potential customers contacted pie chart. So if we were to describe the main feature of the data revealed by the pie charts, it's that more customers were contacted than bought the product. This is as expected. If we have another look, we can write down a couple more features about this. If we have a look at the first pie chart, we can see that Pandora contacts the most clients because they've got the biggest piece of this pie chart. However, in this pie chart here, they make the least sales. So Pandora contacted the most clients or potential clients, but made the least sales. And having a look here, Mervet contacted the least amount of people. However, I think that Mervet's one there looks ever so slightly, maybe about exactly the same as Gemma. So I'll say one of the biggest sales. So Mervet contacted the least people, but was the second biggest, or one of the second biggest sales, because Gideon has made the most sales here. So Mervet contacted the least customers, but made the second highest sales. And we can even add on a bit there saying that Gideon made the most sales. There's lots of things that we could read off these pie charts and compare and contrast. Depending on how many marks the question's worth, depends on how many points you feel that you need to make. Part B, we have the manager wishes to compare the sales staff according to the number of sales completed. What type of diagram would you recommend in place of a pie chart so that the comparison would be made easier? Now, the problem with using a pie chart to try and do this comparison is that it's the area that represents the frequency. So, if we wanted to have a think of how it would be easier to see sales and customers contacted, I think that a dual bar chart would be a better idea to use. Now, we haven't actually talked about Geo Bar Charts, so I'm just quickly going to describe what one of those is. Bar charts, you should have seen at GCSE, which is why we haven't got a full separate section on it. However, Geo Bar Charts you might not have seen. So in a Geo Bar Chart, it's where each person has two bars, one to represent one group, and another to represent something else that the same person has done. Oops, sorry, that's gone a bit funny. I'll have to do. It's only a quick representation of one. And then the next person would also have two bars, representing what they had done. So if we said, for example, that this first set of bar here were for Pandora, and that the first bar let me do a little key. So the first bar that I'm colouring in green, so this one here as well, represents the number of sales, and the second bar, which I'm just going to colour in red, represents the number of people contacted. Then we could also add on who we thought this person here was, so made almost as many sales as they did contacts, and that might have been Mervet. Because if we have a look here, the area of that is almost the same as the area of that. If you think that this has a larger radius than that does there, then Mervet would be quite a good guess, as they made a small amount of contacting, but they did make quite a lot of sales. So a Geo Bar Chart here, that's what it would look like. 2 bars for each person, one representing one piece of data, one representing the other piece of data. Now this should not be over time. This should be 2 separate things, usually divided by a category. In this case, the category is people, and the 2 separate things that we're looking at is sales and contacted. So a Geo Bar Chart representing number of customers contacted and sales made for each employee. This way we can compare sales made and contacts more easily. Because you can easily see here that even though Pandora did contact a lot of people, she didn't make many sales. However, Mervet contacted fewer people, but made sales to almost everybody that they contacted. And you could have that going on for each of the other 3 employees. So it's a good idea now to pause the video and give the Now You Try question a go. So hopefully you've paused the video and given the Now You Try a go. So here we also have the data. We don't have to use the data to put it into the pie charts, okay? Here we have roadside checks on the tyres of 300 cars in a suburban area produce the following data. So we can see if the tyres are satisfactory, slightly defective or seriously defective, and the same results again in a rural area. So here we have a suburban area and here we have a rural area. So here, the first set of checks, we need to remember that this was the suburban area, and the second set of checks, that was in the rural area. So describe the main features of data revealed by the pie charts. So more cars were stopped or checked in the suburban area than rural, because the suburban pie chart is bigger than the rural pie chart. We can also see in both of them that this light grey coloured section is the biggest part of our pie charts. So in both locations, the highest recorded tyre condition is satisfactory. We can also see got 16%, 12%, 10%, 18%, that those have swapped round, okay? So in the suburban area, least, or the smallest proportion of cars were seriously defective, whereas in the rural area they were slightly defective. So then a car manufacturer wants to compare the amount of cars that are driven with satisfactory tyres to seriously defective tyres. What kind of diagram would you recommend in place of a pie chart to compare these two? So again, we could say a Geo Bar Chart showing seriously defective and satisfactory tyres in each area. It's hard to think of another graph other than a Geo Bar Chart that can take over. What one of my pupils came up with, which was quite a nice idea, is maybe from a proportional pie chart. If you have it split into a lot of sections, which is why I wouldn't recommend it for this, but if we had it split into a lot of sections, to rank the order in the first pie chart, rank the order in the second pie chart, and then have a look at SRCC. This is a very nice idea. However, we haven't covered the SRCC yet in the videos, but it is something to think about of if it would be useful, if it's going to show us something, even if it's just to see if there is a correlation between the satisfactory, slightly defective and seriously defective tyres. As I said, 3 points isn't going to work out very well, but if you had 5 or 6 different categories in your proportional pie charts, that could be something that you wanted to have a look at to help you investigate further. Thank you very much for listening.